it means that is giving the first clue itself in the tumor tissue that the molecules coming from the seed oils, those were relatively higher. That is one component. And then when we go downstream to the very targeted, and I just want to mention the caveat that historically the lipids are in the clinical setting classified as LDL, HDL, VLDL, just like classifying the whole world human being into the four set, very high, very short, in between, or something. But here we are trying to see individual kind of lipid and what's its activity. So here again, we further laser focused on the arachidonic acid pathway because we got the clue from untargeted. And then we started focusing kind of down. And then I see when the team approached me, hey, can we do this 10 samples at a very first setting and see what is coming out? Kind of with surprise. My first surprise, I could see the leukotriene B4. Usually this is a very unstable molecule. It's kind of challenging to detect in normal setting, but I could see. For the precursor of leukotriene B4, I was very confident. That is very obvious. And that's how we can start
Yeah.
connect.
And so, Ganesh, just to remind people, so basically the pathway here is omega 6s, the polyunsaturated fatty acids and seed oils.
Right.
They can then go to arachidonic acid, and then the leukotrienes are after that.
In between, there is a molecule called as the phi heat. That is the second generation, and the leukotriene B4 is the third generation. So I was very confident about the phi heat, and the phi heat is very easy to quantitate because it's relatively much more stable than the leukotriene B4. And then I saw that one, and I said, oh, that is very obvious, Tim, because people are eating lots of omega-6, and that's why arachidonic acid, and then there is a phi heat. But I'm kind of really curious to see more samples why this leukotriene B4 is high. Because one thing, in 1983, I believe Ben Samuelson and his colleagues received the Nobel Prize for leukotriene B4 discovery and related molecules. And that time, the resolution of inflammation field was not even born. And then I kind of see surprising, and that's why we start adding more and more samples. And then again, further, we compare to the normal tissue and the tumor tissue from the same patients. And that started making more interest. And we kind of started continuously adding more samples and expanding this project to the next level. And that we are seeing as a complete manuscript as on today, connecting directly to the processed food chain, how that chronic inflammation is there at the site of tumor.
So, I guess one of the punchlines here is, you guys are looking at colon cancer tissue and you're seeing lipid dysregulation and you're seeing basically more pro-inflammatory lipids. Let's just put it in very simple terms. How obviously one plausible hypothesis here as to what the origin of that is that people are eating dietary omega-6 fatty acids because of all the seed oils and everything.